we're getting back to our sum and difference identities here for trigonometry. We went over the sine and the cosine in the last video, and in this video I'm going to emphasize the tangent. Now I had written it once before, but I'll go ahead and write it again here. Notice that the tangent of alpha plus beta, the sum of those two angles, is equal to the tangent of alpha plus the tangent of beta, divided or all over 1 minus the tangent of alpha times the tangent of beta. And when it's subtraction, these two signs switch. The plus minus, the minus, the plus there. So that's a good way to remember. You can kind of keep track of both of them at the same time. In fact, if you think of it, it's as if when this one's a minus, this one's a minus, and this one's a plus. So it might be a way to keep track of it as well. So now, what we're going to do is we're going to use those to find an exact value, and then also to perhaps help us to verify an identity or to simplify an expression, but right now just to find the exact value of the tangent of 165 degrees. So here again, like we did with the sine and the cosine, we need to find a couple of angles that are multiples of 45 and multiples of 30 that add or subtract to get us 165. And the first thing that I think of for 165, you might be different, but I think of the tangent of 165 degrees as the tangent of 120 degrees plus 45 degrees. That way, I have a multiple of 30 and I have a multiple of 45. Now, based on this, since it's a sum, based on this is going to equal the tangent of 120 degrees plus the tangent of 45 degrees all over 1 minus the tangent of 120 degrees times the tangent of 45 degrees. Now, this is a little bit messier to simplify because you're going to have some radicals in the numerator and the denominator. The tangent of 120 degrees, actually the second quadrant, so it's negative, tangent's going to be sine over cosine, so this is going to be negative square root of 3 over 2. Let's see if I got that right. It's going to be square root of 3 over 2 all over negative 1/2, so that'd be negative square root of 3. The tangent of 45 degrees, first quadrant, positive, is the sine of 45 over the cosine of 45, square root of 2 over 2 over square root of 2 over 2. That's 1. So this will be plus 1. All over 1 minus, this is negative square root of 3 times 1. Or, let's see if I bring it way back here, negative square root of 3 plus 1, all over 1 plus the square root of 3. To simplify this radical, remember, you've got to rationalize the denominator, this radical expression. You've got to rationalize the denominator. And to do that, you don't multiply by the radical. Because of the extra term here, you're going to multiply by the conjugate of the denominator, which is 1 minus the square root of 3. Now be careful up top, it's like a little FOIL problem, so that's going to give you negative square root of 3. That's going to be plus 3, square root of 3 times square root of 3, negative times negative is positive. Let's see, then plus 1. And minus the square root of 3, and that's all over 1, because these are conjugates, the O and the I cancel, so 1 minus 3. So this is going to give me, looks like 4 minus 2 square roots of 3, all over negative 2. And that simplifies because you can divide negative 2, and I get negative 2 plus or minus the square root of, plus or minus, let's try that one more time. Negative 2 plus the square root of 3. And that's my answer right there in simplest radical form. So it takes just about, actually maybe a little bit more time to simplify it than it did just to go ahead and plug in and find the initial expression. Alright, that happens quite a bit with the tangent. Now remember, that's 165. That's a little messy. Alright, now there are some more identities. The next 6 identities here on the cofunction identities, remember that co and cofunction. You have sine, you have cosine, you have tangent, you have cotangent, you have secant, you have cosecant. And what they're saying essentially is that if you have, especially if you have acute angles here, that the sine of an angle is equal to the cosine of its complement. This being the same as 90 degrees. But it doesn't have to be an acute angle. You can do this for any angle, but that's one way to kind of keep track of it. Notice that the sine of theta is the cosine of the quantity pi over 2 minus theta. The cosine of theta is equal to the sine of pi over 2 minus theta. Back in the old days when they had trig tables in the back of the book, because there were no calculators to be found, they took advantage of that quite a bit to set it up to have less pages used for the sine and the cosine trig tables. The tangent of theta is the cotangent pi over 2 minus theta. The cotangent theta is the tangent of the quantity pi over 2 minus theta. And, not that you can't read this, the secant of theta is equal to the cosecant of the quantity pi over 2 minus theta. The cosecant of theta is equal to the secant of pi over 2 minus theta. And the periodic identities, I don't think I can remember too many times where I actually had to write down that I was using the periodic identity, because I just get so used to the fact that these functions are periodic. Sine, cosine, cosecant, and secant all have period 2 pi. So if you add 2 pi onto an angle, you get a coterminal angle. Therefore, you're going to have the same sine, you're going to have the same cosine, the same cosecant and secant. Now, it's a little different with tangent and cotangent because they're periodic, but their period is pi, or 180 degrees. So you can see that it applies here. That says the cotangent. I know it looks like a parenthesis, the cotangent of theta. There's a little bit of a space in there. I don't always write it down. I kind of almost connect it like it's all one word, but the cotangent of theta probably would be better written if I make sure that I leave a little bit of a space there and you can see it a little bit more easily. I also have noticed that students sometimes, when they're trying to find a value for sine, or cosine or tangent or any of them, let's just say sine, and it turns out that it's a half, they'll write the sine equals 1/2. Well, that doesn't really make sense, because it's not the sine that equals a half, it's probably the sine of the angle that equals 1/2. So make sure that you're using the variables appropriately when you're writing expressions like that. Okay? Alright, so we'll cross that out. Now, let's verify an identity. The top identity here is saying that the cosine of 3 pi over 2 minus theta is equal to negative sine theta. Well, this is not the cofunctional, although it kind of looks like it, except that it has a 3 pi over 2. Instead, I would use the difference for cosine, the difference identity for cosine. I would rewrite this. Now this is the cosine of the first angle times the cosine of the second angle plus, remember it's the opposite sign, the sine of the first angle, the sine of the second angle. And that equals negative sine theta. Now what is the cosine of 3 pi over 2? Because that's a variable, I don't know what this is, but I can figure this out. Well, that turns out that's 0. So this is 0 times the cosine of theta plus sine of 3 pi over 2 is negative 1 times the sine of theta. Oh, you can see it falling apart right now. We know that 0 times the cosine of theta is 0, and negative 1 times the sine of theta is negative sine theta equals negative sine theta. This one checks out okay. You can QED that one if you want to. There's another guy. And in this one also, I think you will find that using the sum and difference identities for sine are really going to make this fall apart. It's a little bit long to write out, and I hope I've left myself enough space, but we'll give it a shot. I'm going to take the sine of x plus y, which is the sine of x, cosine of y, plus cosine of x, sine of y. And then I'm going to subtract from that minus, in parentheses, the sine of x minus y, which is the sine of x, cosine of y, minus the cosine of x, sine of y. Said it was going to be quite a bit to write out. And that equals the right side here, which is 2. Oh my goodness, I've not given myself enough room here. Cosine of x, sine of y. Sorry about that being so sloppy. Well, this is kind of like a negative 1 here that you're going to distribute by. And because I'm going to try to save a little bit of space here, so I don't have to write it into the next line or the next column over there, I'm going to distribute this by, this is going to be negative 1 times this is going to be negative, and negative 1 times the minus is going to be positive or plus. So I'm going to have sine of x cosine of y. Fan mail from some flounder? No, there's no name on it. Alright, so, see if we can get that turned off. There, we got it. So the sine of x cosine of y minus the sine of x cosine of y, those are going to cancel out. That's nice. And then I have the cosine of x here, sine of y, and minus and negative is plus, plus the cosine of x, sine of y. You can see it coming. I hope you can anyway. So I'm going to combine those because they're like terms. So I have 2 cosine x sine y. equals 2 cosine x sine y. Now remember, with the identities, you want to start with the most complicated side. Notice here, that was more complicated than that. The left side was more complicated than that. All right? And that's your verification right there. Now the last guy that I wanted to talk about in this section, it's not really emphasized a lot in this particular book, but you will see reduction formulas in calculus, probably the second semester of calculus, where you're trying to simplify expressions by taking expressions that have two trig functions and write them as an expression with one trig function, reducing it, reduction formula. And they put one of them in here, and it has to do when you're adding expressions that look like a sine x plus b cosine x. Notice the same angle. That's important. For all real numbers a, b, and x, a sine x plus b cosine x, remember it's the sum, is equal to k times the sine of the quantity x plus alpha. And you say, well, where's the k and where's the alpha from? Well, the k is the square root of a squared plus b squared from these numbers. And alpha is such that the cosine of alpha is a over k, that's this guy right here, the k, plus the sine of alpha is b over k. Now remember, we find k here, the a and the b are given, so we'll be able to determine by their SIGN, S signs, what quadrant they're in, and be able to figure out the angle. So we'll try one example here just to give you a little taste of it. It says write negative 4 sine x plus 3 cosine x in the form k sine of the quantity x plus alpha. Well, I'll start out by finding k. A is negative 4, b is positive 3, because it has to have the sine first and the cosine second, and this one's all nicely set up. They might want to try to throw a curveball at you and have it turned around. But I have a is negative 4 and b is positive 3, and now I need to figure out what k is. K is the square root of negative 4 squared plus 3 squared. Oh, that's convenient. That's 16 plus 9. That's the square root of 25, which is 5. And what else do I know? I know that the cosine of alpha, and I have to find alpha, is a over k, so that would be negative 4/5. And that the sine of alpha is b over k, so that would be 3/5. Now notice, cosine is negative, sine is positive. We're talking in the second quadrant. This is quadrant 2. So now I'm going to grab Mr. Calculator here, and I'm going to do an inverse cosine. And I'm going to do the inverse cosine because remember, the angle that's given with an inverse cosine is between 0 and 180, or between 0 and pi. So it makes most sense to use this. If I use this one, I get a fourth quadrant, or a first quadrant angle, and then I have to use the reference angle, an extra step. So being a lazy kind of guy, I grab my calculator over here. I'm going to find alpha to be the inverse cosine of negative 4/5. So make sure it is in degree mode. Mine is not. Mine is in radians. So I make sure of that. And then, let's see, I'm going to take inverse cosine of negative 4/5. And I'll hold it up here again so you can see it. Hopefully you can see that okay. And I'll hit equals. And you can see it. At least I hope you can. There we go. And I get 143.13, etc., etc., etc. It does not say where to round to, so I will round this to 1 decimal place just for my convenience. And that would be in degrees. So I want to write it into this form. That means that negative 4 sine x plus 3 cosine x is equal to k, which is 5, the sine of x plus 143.1 degree. And that would be the answer to that. So hopefully you get a chance to try at least one of them in your practice and such. And that finishes up most of what you'll probably come across with involving the sums and difference identities for sine, cosine, and for tangent.